Okay, this is going to be a good review of all the derivative rules: product rule, quotient rule, chain rule. So this is going to put them all together. The first problem is quotient rule. And if we want to remind ourselves what that is, that's low d high minus high d low all over low low. And let's go ahead and start that out. We've got the lower function. Again, they want to know what h prime is at 0. So I'm going to say low at 0 times the derivative of the higher at 0. Low d high minus high d low all over low low, g of 0 squared. I'm going to go to my table. G of 0 is 2. F prime of 0 is 4. Minus f of 0, 3. G prime of 0 is 5. All over g of 0 squared. 2 squared will be 4. And I'm left with 8 minus 3 pi all over 4a. 21 is talking about the chain rule because I've got an outer function and an inner function. So h prime of 1 will be the derivative of the outer, f prime, leave the inner, g of 1, times the derivative of the inner, g prime of 1. All right, g of 1 is 3, so I'd have f prime of 3 times g prime of 1, which is negative 2. F prime of 3 is 7. 7 times negative 2 is negative 14b. So A wants us to write the equation of a tangent line, and for the equation of a tangent line, I'm going to need a point and a slope. I've got a point when x is 3, but I don't know the y. I could plug in 3 to my function to go ahead and get what k of 3 is. So k of 3 would equal to f of g of 3. G of 3 is 6, so k of 3 is f of 6. F of 6 is 4, so my point would be 3, 4. There's my point. I need a slope, therefore I'm going to need k prime. K prime of x, again, this is going to be chain rule. Derivative of the outer, leave the inner, times the derivative of the inner. They want the slope when x is 3. So we got f prime of g of 3 times g prime at 3. And I use that table. G of 3 one more time is 6. G prime at 3 is 2. F prime of 6 is 5. So I get k prime of 3 is 10. My slope is 10. My point is 3, 4. So the equation of the tangent line would be y minus my y equals my slope, x minus my x. And I did it. Part B asks for h prime of 1. When h involves division, I've got to go ahead and use the quotient rule. So I'll have low d high minus high d low all over low low. F of 1 is negative 6. G prime of 1 is 8. G of 1, 2. F prime of 1, 3. F of 1 is negative 6, and we got to square it. I'd be left with a negative 48 minus 6 over 36, leaves me with a negative 54 36ths. 18 goes into each of these. 18 goes into 54 3 times. 18 goes into 36 twice. My answer is negative 36, negative 3 halves, but because this is free response, you could have been done right here. All right, if they want the derivative of f, notice that I've got one function and another function. So we're going to do the product rule. The product rule is f prime times g plus g prime times f. When I do f prime, the derivative of e to the anything is e to the anything times the derivative of the exponent. Leave g plus g prime times my f function. They want this whole thing. This is f prime. This is f prime of x. They want f prime of 2. So I'm going to go ahead and plug in a 2 to my function. So I'd have e to the 4 times 2. 2 cubed would be 8 plus 1. 2 squared is 4 times 3 is 12, e to the 4th. I'm going to simplify this a bit. So I'd have 8 plus 1 is 9 times 2. I'd have 18 e to the 4th plus 12 e to the 4th gets me 30 e to the 4th. Okay, 13 wants us to take the third derivative. Just for fun, the third derivative is called jerk. So the first derivative, dy dx, is the derivative of cosine, which is negative sine, minus the derivative of natural log is 1 over 2x times the derivative of the 2x, which is 2. I'm going to simplify that to be negative sine of x minus 1 over x, and that is the same as negative sine of x minus x to the negative 1. That's the first derivative. I do that because the second derivative is going to be easier going from here. The derivative of negative sine would be negative cosine. The derivative of negative x to the negative 1 would be positive x to the negative 2. And finally, that third derivative of negative cosine is positive sine. The derivative of x to the negative second is minus 2x to the negative third. That answer is A. Oh, this refreshes us on the derivatives of inverse trig functions. The derivative of inverse sine is 1 over the square root of 1 minus the angle, in this case it's x squared, times the derivative of that angle, which is 1. Okay, so we found the derivative. They then want that derivative at root 3 over 2. So we've got 1 over root 1 minus root 3 over 2 is being squared. Therefore, we've got 1 over root 1 minus root 3 squared is 3. 2 squared is 4. We've got 1 minus 3/4 is 1/4. It's an excessive square root sign. The square root of 1/4 is the same as square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. 1 divided by a half is the same as 1 times 2. My answer is 2. Before they go expecting me to take the derivative of this ugly thing, I'm going to rewrite my function as x to the 1/2 plus 3x to the negative half to help me. The derivative of x to the 1/2 will be 1/2 x to the negative half minus 3/2 x to the negative 3/2. Bring that exponent up front, take 1 away. Okay, I'm going to rewrite this as 1 over 2 root x minus 3 over 2. I'm also going to bring that x down and make my exponent positive. They want to evaluate that when x is 4. So I'd have 1 over 2 root 4 minus 3 over 2 times 4 to the 3/2. Okay, this is going to get me 1 over 2 times 2 minus 3 over 2 times 4 to the 3rd power square rooted. You could do 4 cubed, or you could do the square root of 4 first. I'm going to do the square root of 4 is 2. 2 cubed is 8. So I'm going to have 1/4 minus 3/16. That's the same as 4/16 minus 3/16, getting me an answer of 1/16. Okay, they want the derivative of f of g. We're going to have to do chain rule. Derivative of the outer, leave the inner, times the derivative of the inner. And what we do know is our f function. F is x squared, and notice that we need an f prime. So I'm going to go ahead and take f prime of x is 2x. And notice what this is. We need to take f prime of g of x. That means we're going to plug g of x into our f prime. Well, here's our f prime, so I'm going to go ahead and plug in g of x to our f prime. So again, my f prime is 2x. I'm going to substitute in my g of x in for the x, so I'd have 2 g of x's. I still need to bring over my g prime, and that's ironically, strangely, my final answer. All right, when they want the derivative of sine times cosine, we need to do the product rule of fig plus gif. The derivative of f, or the derivative of sine, is cosine. Leave the second function. This is f prime times g right here. Plus, we got to do g prime, derivative of cosine is negative sine, times f. And we could rewrite this as cosine of x squared minus the sine of x, that quantity squared. They want to know what is that derivative when x is pi over 3. I'm going to plug in a pi over 3, and we got to think back to our unit circle. The sine at pi over 3 squared. The cosine at 1/3 of a pi is going to be 1/2. When I square it, I'd get 1/4. The sine at pi over 3 is root 3 over 2. I'm going to go ahead and show this one. When I square this, I'm going to have And root 3 squared is 3. 2 squared is 4. 1/4 minus 3/4 is negative 2/4 or negative 1/2. If they want the slope of a line, we got to go find the derivative. The derivative of natural log of 2x is 1 over 2x times the derivative of 2x, which is 2. My 2's are going to cancel, and I'd be left with the derivative is 1 over x. They wanted that slope or the derivative when x is 4, so my slope is going to be 1/4. Okay, they gave us f. Let's go ahead and find f prime by taking that derivative. F prime of x is going to be negative 8x to the negative third, and 2/4 or 1/2 x to the first. Derivative of 4 is 0. I'm going to go ahead and rewrite this as negative 8x to the third in the denominator and 1/2 x. I'm going to make sure that that x looks visible, that it is out front. Actually gets multiplied by the numerator. We're going to analyze this when x is 2. Therefore, I'd have negative 8 over 2 cubed, which is 8. And 1/2 times 2, lots of things cancel. I get a negative 1 plus half of 2 is 1. So I get an answer of 0. This next question has extra chain rule hiding inside. Can't forget when the trig function is written with this cube here, that really is saying that we've got the sine of x squared and that quantity is being cubed. So when we do the chain rule, this is my outer function, this is my inner. We're going to take the derivative of that outer function first. So I'm going to bring that 3 out front. I'm going to leave my sine of x squared. I'm going to take my exponent down by 1. Now I'm going to take the derivative of sine, which is cosine, but leave the angle. Then I'm going to multiply by the derivative of the angle, which is 2x. My 3 times my 2x gets me a 6x, and I've got answer E. I'm going to go ahead and use quotient rule to find the derivative here. I'm going to do low d high minus high d low all over low low. All right, then it's just a simplifying game. We can handle that. I'm going to distribute my negative. So I'd have 1, I'm going to have an x squared plus 1, because anything times 1 is just itself, minus, I'm going to multiply 2x times x and subtract it. So I'd have minus 2x squared minus a 2x all over. I'm not going to distribute that denominator out, because when I look over here, I notice that many of them are not distributed. I'm not sad about it. And then when I combine negative 2x squared plus 1x squared, I get a negative 1x squared minus a 2x plus a 1 over that denominator. And that looks like C. Okay, on this next one, we get a calculator. It says that the position is x, then the derivative of position, or the velocity, is given, and they want to know the acceleration is 0 at what t value, or what x coordinate. The acceleration is 0 when. So I'm going to go ahead and plug in, I want the acceleration. So I'm going to ask for the derivative. I'm going to go to my graph menu. I'm going to type in my y1. I'm going to say, I want to graph the derivative of my velocity to get acceleration. So I'm going to type in the derivative, and I want it to graph the entire thing. And when I graph the derivative of velocity, I get this graph. This is just in a standard Zoom 6 window. And it says, I want to know at what x value, or what t in this case, the acceleration is 0. Again, this is a graph of acceleration. So at what value is my acceleration 0? I'm going to do second calc 0 to calculate this value here. And I got 1.243. All right, if we're taking the derivative of this with all these variables in it, okay, a is just a constant, y'all. A is just a number. So you could picture this as 5e to the negative 5x. I know that you guys are really good at taking the derivative when we've got constants in there. The derivative of that 5e to the anything will be 5e to the anything times the derivative of that anything, which is another negative 5. So let's just replace my 5's with a's. So I'd have an a e to the a. That does not show up very well, does it? Let's try this. If I did, let's try red. So let's say we had a e to the negative a And then we've got another negative a over here. I've got a negative a, so let me write that. That'd be ae to the negative ax times negative a. Negative a times my a gets me a negative a squared. I like that. Oh yeah, I like e. Okie dokie. They gave the position of a particle as the following. They want to know when is the particle at rest. That's going to happen when its velocity is 0. We got to go find the velocity, which is the derivative. The derivative of sine is cosine, leave the angle, times the derivative of the angle. The derivative of 2 pi t, 2 pi are just a constant, so that's going to be my derivative. They want to know when is that velocity 0, aka when is the particle at rest. I'm going to go ahead and set this equal to 0. Therefore, I'm going to say I've got 2 pi times the cosine of 2 pi t equals negative 2 pi. I'm going to move this quantity over. I'm then going to divide by my 2 pi, and I'd have cosine of 2 pi t equals negative 1. And what we've got to think about here is when is the cosine equal to negative 1? Well, on a unit circle, the cosine is equal to negative 1 at pi. This is the coordinate negative 1, 0. So I need this quantity in here to be pi. So when is 2 pi t equal to pi? I could divide out my pi's. I can even divide my 2 with it just to get my t by itself. And I'd have t equals 1/2.